Okay, so this is the video part 2 of Hess's Law, the lab. And so what we're going to do is we're going to take the data that we collected and we're going to work through the math page by page. Okay? So for the second page of your data and observations, it asks you to calculate Q. Q is just heat, right? Of each reaction that we've done. And remember, we did 4 cups or 4 calorimeters. So we did magnesium with HCl, magnesium with HCl. We did it twice. I'm going to call that reaction 1 and reaction 2. Then we did magnesium oxide with HCl twice. So let's call that reaction 3 and reaction 4. So you've got to repeat the calculation for all 4 of the reactions. Okay? And I'm going to do one as an example, and then you've got to obviously use your data to do all the other 4. Okay? So for page 2, you're going to take Q of the reaction, and you're going to say equal to M. M is the total mass. This is not mass of just the magnesium. It is the mass of the magnesium plus the HCl. Everything in the calorimeter. Okay? So it's going to be 100.2088. 2088. Okay, you're going to multiply that by S. S is the specific heat. The specific heat for an aqueous solution is 4.18 joules divided by grams degrees Celsius, because you are assuming that the majority of the solution is water, and this is the specific heat of water. Okay? You're going to plug in your final minus your initial temperature. Okay? And of course, you're going to solve. Now remember, this is in grams. This is in joules divided by grams degrees Celsius. This is in degrees Celsius. So if you multiply these units together, your grams cancel out, your degrees Celsius cancel out. Your answer here for each of the 4 reactions should be in joules. Okay? So I would pause the video and do this calculation with the data that you just collected for all 4 reactions. Okay, once you have that done, you're going to move on to the next page. The next page asks you to find the number of moles of Mg that reacted and the number of moles of MgO that reacted. Okay? To do that is a very simple conversion factor. In the first reaction, for example, we did 0.2088 grams of magnesium. We're going to convert it with the molar mass of magnesium, 24.305. Again, this is from the periodic table. And you're going to get moles of Mg. And again, you should repeat it for reaction 1 and reaction 2. Of course, the mass is slightly different. It's really close to 0.2. You should use real numbers to get reaction 1 and reaction 2. Okay? The third and fourth reaction, remember we did it with the white solid powder, which is the magnesium oxide. So again, this is for reaction number 3. I put 0.4962 magnesium oxide. And again, the molar mass of magnesium oxide is 40.304. This is the conversion factor. Okay? And you're going to get moles of magnesium oxide. And you're going to do this for reaction 3 and 4. Obviously, you're going to use the various masses of magnesium oxide from your previous page. Okay? So now, if you take a step back, you're looking at this. Page 2 gives you the Q of the reaction, the heat. Page 3 gives you the moles. Okay? Page 4 asks you to solve for the heat of the reaction. And again, you're going to do this for each one of the trials that we've done. And the heat of the reaction is basically how much heat is released per mole. Okay? Because the heat that you calculated before was not per mole, it was for 0.2088 grams of magnesium, for example. So what you're going to do is you're going to go Q of the reaction 1 divided by the moles from reaction 1. That's a number. You're going to write it down. Again, you're going to get Q of reaction 2 divided by moles of magnesium from reaction 2. And again, because Q is in joules, and N is in moles, your answer here should be in joules per mole. All right? And again, you're going to do this for reaction 3, except you're going to use heat from reaction 3, moles of magnesium oxide from reaction 3, and for reaction 4, you're going to say heat from reaction 4 and moles of MgO from reaction 4. Then what you're going to do is you're going to average the reactions. You're going to go the average of reaction 1 and 2 and the average of reaction 3 and 4. Because remember, reaction 1 and 2 are basically just the same. It's just trial 1 and trial 2, trial 3 and trial 4. Okay? So I'm going to step out of the frame of the video, and I want you to make sure you do all of this. And again, I would pause the video if you need to, and make sure that you do the math associated with those values. Okay? I would like to also point out to you that because these are exothermic reactions, your delta H should be negative. Should be negative joules per mole. Okay? Because your Q here should be negative as well. Okay? Because they are exothermic reactions. If you think back to when you were doing the reaction got warmer, right? The temperature increased. So it's releasing heat. When it's releasing heat, it's an exothermic reaction. Okay? The way I like to remember it is if it's releasing heat, it look like an X. Releasing heat, exothermic. Okay? When you're absorbing heat, you look like a lowercase n, endothermic. I don't know if that helps. That helps me. But in this case, because you're releasing heat, the temperature is increasing. Your Q and your delta H should all be negative. All right. Last but not least, the 5th page. I want to push this part out of the way. This is really where you're going to take your delta H and you're going to go ahead and calculate it. Oh, wait, one more thing before we do that. When you do the average, come back here real quick. When you're doing the average of the reactions, okay, your answer will be in joules per mole. You do need to convert it to kilojoules per mole. So you need to convert 10 to the 3rd joules, 1 kilojoule, 10 to the 3rd joules, 1 kilojoule. This allows the joules to be canceled out, so you are in kilojoules per mole, kilojoules per mole. All right? So really, this is going to be your value, and remember it's negative and negative. Okay? For this reaction here, magnesium plus 2HCl gives you magnesium chloride and H2. Okay? And then for the second reaction, remember we reversed it because MgO and HCl, what we started with, is now written as the products. Because it is reversed, when we flip the reaction is negative. Okay? So this is already negative. You're going to negative a negative, so it becomes a positive number. Okay? So this should be a negative number. This should be a positive number, because negative times negative is positive. And this number here is from your textbook, so we're not going to change that. And again, we're just going to apply Hess's law. HCl cancels out, H2 cancels out, MgCl2 cancels out, okay, and water cancels out. We bring down what is left over. Okay, and what we're going to do is we're just going to add this up. This, and this number. So this number is negative. This number should be positive, and this number is negative. Okay? We're going to add up all of these numbers and write it here. Okay? This will get you delta H for this reaction. Okay? And this is what we call our experimental value. Okay? And again, it should be in kilojoules per mole. Okay? Now, if you look in your background reading, in the pre-lab, the reported is 601.8 kilojoules per mole. Okay? So last but not least, on page 5, you're asked to calculate the percent error. Okay? So just as a review, percent error is the reported, so minus 601.8. Subtract your experimental, divided by your reported, 601.8, times 100. That's going to give you your percent error. Okay? And once you have all of this done, you're going to submit this data, page 1 through 5. You're going to upload it on Canvas for it to be graded for 20 points. Okay? After you are done with this data and observations for 20 points, the next thing on Canvas is to do the post-lab assignment. And again, the post-lab assignment is on Canvas, also worth 20 points.